All right, welcome back everybody. Today I'm just going to do a hopefully short video of the project that we were working on for the hackathon. So we just had the institutional hackathon of 2020 between the Biostatistics and Bioinformatics departments. And so I'll share kind of what we had come up with over the day and a half that we had worked on it. On the left-hand side here, you can see that we have that Shiny app, and I just have the GitHub for it open right now. There are a handful of other different projects. So there was one that was creating an R package. There was one that was looking at Apple HealthKit, another one that was using natural language processing to do kind of like a query search to find different abstracts of other people who maybe we're already looking at a project idea that you had. So you could search for something like machine learning in cancer research, and it would come up with a query of all the other abstracts by other researchers at the institution who had those key phrases within their abstract or maybe even title. In the future, I think they were going to work on other things like whole body searches for the whole text. But yeah, there was a lot of really interesting stuff in here. The team that actually won was this utilizing target lesion heterogeneity to assess treatment efficacy. So there were two big groups, and that was one of the big groups, and the other one was the team that I was a part of, which was building the Shiny application to visualize and do a quick visual analysis of immunofluorescence data that's output by a program that's titled Halo, I believe. So if we go over into this application, I will load in the data. So you can see right away, it looks nicer than other Shiny applications. So in other Shiny applications that I've made, you have this sidebar across the top and you can do the different tabs and stuff. And it looks more from the 1990s, but this looks really nice. So we'll choose and import some files here. So I'll drag in our summary file. I'll drag in our clinical file if it lets me. And then I'll also drag in a spatial data file that's output from that Halo program. So the spatial data file has all the different markers. So there's CD3, CD8, Fox, what else was in there? Just a bunch of different markers and then combinations of it, and each cell that had that marker come up gets a little XY coordinate. So then we'll go on to the next page. Another thing that you can notice here is that we had to put in a merge by ID here. So maybe in the first table and the second table, they're not the same ID, but we have made that drop down that way. I mean, it'd be easier later on in the code in order to merge between the two. At the very top is a summary table. It shows the min, the max, for whatever dropdown you have. So we can see here we have total cells. The min here is the minimum number of cells in a sample that had markers show up. And then you have quarter one, quartile, median, mean, so on and so forth all the way through. So you can see here too that we had in this particular summary data file 257 samples, and then in the clinical data file that would be mapped to 257 patients. In the samples file or in the summary file, you could have each patient having multiple samples. So you could have like triplicates, for example, and then this number would be 3 times higher than the number of subjects. The drop-down menus here on the left-hand side will change the box plots. Oh, puppy's sad. We can do age, for example, if we want to look at age, total number of cells. It doesn't really make sense to have a box plot, but it can be. Or we can do a scatter plot, and then we get this really nice XY plot. If we do back to race, maybe we can do histogram. You can see the distributions of race and then the total cell that have markers. On the bottom here, we have a heat map. Something that we do need to work on if they want my help in the future is this annotation here on the top. We don't have like a key for it, but if we're looking at race, you can see on the top black, unknown, and white, and the different colors. We have red, purple, and then green. You can look at different things like HIV status too, and it'll recompute. We have two different colors for positive and negative. On the bottom here, we can go ahead and select any of the different percentages. So if we're interested in, say, FOXP3 for Treg cells, we can keep that ticked and untick everything else and see if maybe for just Treg, oh, we need two of them. Okay, we'll do T cells and then Treg. See if there's any clustering happening for the annotation. It's not clustering by annotation, and that's something that could also be done in the future, I suppose. But it's all interactive, which is super, super handy. So that's the summary data page. If we go to the spatial data page, this takes a while because it has to go through and compute, Monte Carlo simulations for the confidence envelope. But on the top here, we can see we have the different markers. So initially we have selected just the single markers. We can see PDL1 is in yellow. It's really difficult to see the small dot, but you can see the distribution on top. So if on the bottom we want to look at PDL1 to see whether or not there is clustering for it. And I don't know, there's a lot of cells, so this might take a while too. Yeah, it's going to take a really long time. We're going to restart the Shiny app, otherwise it's going to take a long time to run. So just on the last page, we just need clinical and then our spatial data file. Okay. We'll look at the different metrics. So we can look at Besog's L. So we can see that above the line is clustering and below the line means dispersion. And so isotropic and translation are two different edge detection methods. So if there's a cell on the edge here and we look at this circle and we go R out, so however many microns out, we can see that if we're on the edge, we're going to have half of our circle, half of our theoretical circle around that point not have anything. So you have to have either of the different methods of detecting that edge and removing that. So if we're on the edge here and it's a pretty straight line where it would be like a good one here, and we go this far out, we could remove half the circle's area to compute K or L. If we go to Macron's M, this is centered around 1. So anything below 1 means that there is less than the expected amount. Anything above 1 means that there's more. So 2x at, say, 50 microns means that there's 2 times as much clustering happening than what would be expected of the value 1. But yeah, this is a really interesting project. And let's see if we add summary. If it'll recompute the summary page. Yeah, and we get back the information. But yeah, it was a really interesting project, and hopefully in the future they do another one, because it's great to work with so many different people, learning different things and working through the problem. But yeah, if you guys want to see me work on my Shiny app, so my Shiny app is for the copy number variation, let me know, and I can just work on it and kind of record the highlights of what I'm actually doing. That one's pretty fun too. But yeah, let me know what you think. Thanks.